flip this page horizontally. Perfect, thank you. Okay, so we're in the last bit of this. Like I said, this is gonna go really quick, I hope. Okay, so this is yours. Okay. If you look at that one, let's see. What can we say about this? Can we make the denominator 0? Can we make the denominator 0? Okay, let's see, non-permissible values. Non-permissible values. What are the non-permissible values? So x squared plus 1 cannot equal to 0, so I bring that over there. The other side of the equation, so negative 1. And I'm supposed to take the square root, so x is equals to, okay, now we have a problem here, right? Because we can't take a square root of a negative 1. It's not a real number. So here, what can we conclude? There's no non-permissible value. If there's no non-permissible value, means no holes, no vertical asymptote. Okay? So here we can say, therefore, no hole and vertical asymptote. Okay, this is something that haven't quite really seen. Or maybe we've seen one of the questions from the book. Okay, now what about the horizontal asymptote? Okay, no common factor to cancel. And we know the degree of P of x is less than the degree of Q of x. So what can we conclude there? The denominator gets big so fast that overall it's going to approach to 0. So y is equals to 0. So y equals to 0 is the horizontal asymptote. Okay. What else do we know? We need to know. We need to figure out the x-intercept and y-intercept. Okay? So let's go y-intercept. Set x equals to 0. So y is equals to 2 over 0 squared plus 1. So that's 2 divided by 1 will be 2. So y-intercept is at 2. Let's do the x-intercept. X-intercept, we're going to set y equals to 0. Okay. Now if we set y equals to 0, we're going to cross multiply to get rid of the denominator, right? Then we're going to end up with 0 equals to 2. Okay, now we're going to have a problem again, right? Because that's not true. 0 is not equal to 2. So what can we conclude here? No x-intercept, right? So let's see if we can just figure this out. Okay. We just realized that there's no vertical asymptote. Okay. And we also know that there's a horizontal asymptote. At least we can do that one. Let's do that. Okay, so that we're going to label that y is equals to 0 is our horizontal asymptote. Now we know that y-intercept is 2, so that's 2 there. Okay, so this is what we have so far. We got a line here and a point there. Okay, so do we know how this thing is gonna go? We don't kind of know what's going on yet, right? Okay, so what can we do? Test points, right? Test points. So let's test -1 and +1. So let's go ahead and do test points at -1, +1. Okay, so if x is -1, the y is +1, right? -1, 1. And then if it's x is 1, y is 1. Okay, so kind of go like that. Well, can you predict how this is going to go? As x gets bigger, what do you think the value? It gets closer and closer to 0. So it's going to go like this. Like that. That was a fast one. Okay, you like that one? Okay, good. Any questions about that? That's a fun little graph. Let's see the next one. See what happens. Let's, can we factor the denominator? No, it's not difference of squares, right? Okay, so let's take a look at the non-permissible value. Okay, we're pretty much getting the same problem as the previous example. We're going to run into x equals to the square root of -5, which is non-real number solution. So that means we can conclude that therefore no vertical asymptote and no hole. Okay, good. No vertical asymptote and no hole. Now, what about the horizontal asymptote? The degree of p of x is less than the degree of q of x. So that means therefore y is equals to 0 is our horizontal asymptote. Okay, so we see horizontal asymptote. Let's see. Oh, now this is going to be a little bit weird. Okay. Now let's go ahead and figure out the x-intercept and y-intercept. Okay. x-intercept, we're going to set y equals to 0. Okay. I will have to cross multiply here. So you're going to get 0 is equals to x minus 4. Therefore, x is equals to 4. Okay. So x equals to 4. So x-intercept is 4. This is going to be really, really weird. Okay. Now let's take a look at the y-intercept. So y-intercept, set x equals to 0. Okay. So far so good? Did you get negative 0.8 for your y-intercept? Yeah? Okay. Now, we got all those puzzle pieces. Let's put them together to make a graph. So no vertical asymptote and no hole. Great. Y equals to 0 is our horizontal asymptote. That one we could do. So I'm just going to go y equals to 0. I have to label my horizontal asymptote. Okay. Now, this is the weird thing. Okay. X-intercept is 4. 4. Now, you're probably like looking like, what? Are you asking a question right now in the back of your mind? That's a good question. Like, how can this graph intercept the x at negative 4 when there's an asymptote there? Like I said, this is a weird one. Let's finish it off, okay? Let's see here. Y-intercept is negative 0.8. So negative 0.8. So this is... Okay. We can't really figure out the ending of this kind of... How can we deal with this? Let's do a little bit of test point here, okay? So let's go to negative 1. If x is negative 1, what would the y value be? If x is negative 1, what is the y? Okay, if x is negative 1, so negative 1 minus 4, negative 1 squared plus 5, so that's negative 5 over 6, negative 5 6, which is negative 0.8333. Right there. Now let's take a look at if x is 1, positive 1, what would it be? Negative 3 over 6, which is negative 0.5. Okay, good. Okay. Let's pick something past the 4. Because we're doing all these things because this is the weird one. Okay, let's pick 5. If x is 5, what happens? One over 30, right? Which is something in a positive. Okay. So can we figure out what the graph looks like? There's a little bit of a thing in here. That's what the graph looks like. It looks like that.
I mean, like, on the side of the, on this side, there's a curve that goes upward, and then,
Yeah, so this is gonna start to
well, I just, one straight.
this way,
No, the other side of the eccentricity, but when it's straight down.
straight down this way,
No, straight line, it's gonna,
this way.
no, this way. The line goes like all the way.
Okay, you gotta show me what you meant. 'Cause
So the line-
oh no, it won't go that far down because when you look at this is going to give us like closer and closer and closer to 0, closer and closer and closer to 0 here. So that's what that graph looks like. Okay, let me finish this one first. Did I give you that? Okay, yeah,
I just
in a
want to
second.
know if it's due because I have to go pick my
Oh,
daughter.
yeah, today. Oh, yeah, go.
It's
It's Tuesday.
Tuesday.
Yeah. So let's see. This is like Desmos on my phone. Okay. Like looks like that. Just kind of like what we have. And then this part here, that is such a weird thing is when you think that you have an asymptote and you can get closer and closer. What's happening here is you get closer and closer to this and it manages to cross over, but then after it crosses over, this thing just kind of hovers just above the asymptote. So that's a really neat one. You're going to see that on the test? Probably not. You're going to see the convention, hyperbolus, and all that. Okay? But that's a cute one to deal with. Yeah, for this one, yeah, it's possible to cross over and then just hovers, gets closer and closer and closer to that. Okay? So that concludes our lessons. You have assignment time over here, something for you to work on. Okay, highly encourage you to do that. You have 4 days, extra long weekend. And I did talk about this one. This is your hand-in assignment number 3, due on Tuesday, because I won't see you tomorrow. Okay, so just to make sure that you're showing everything. Now over here, when there is, let's say, no vertical asymptote or no horizontal asymptote, don't leave it blank, just put none. Okay? Because if you leave it blank, I don't know if you know what to do or you, right? So just put none if there's nothing.
So you show our work in those boxes
Yeah.
too, or-
Yeah. You can squeeze it in. This question over here, it's like a matching type. Okay. All you have to do is just match which one's the right thing. There's one extra graph that is not matched with anything. Just to let you know. Okay. So don't go like, oh my gosh, like what do I do with the other one? And then finally, we've finished this topic with graphing. Okay. So important things in here. So graph the following functions. Label on each graph the equation of any asymptote. You got to label the asymptote. Any x-intercepts and y-intercepts, if they have. And then coordinates of any hole. Good.
Then I can skip the non-pushable value.
Come again?
Am I able to skip the non-pushable value? Because the question didn't ask for a non-pushable value.
Yeah. You can skip that one, but you actually would need the non-permissible value for a vertical asymptote and for the hole. So the non-permissible value leads you to that direction. So you still have to figure those out. Okay, so that's good. We have about 20 minutes, so you can get started with your work, either this hand-in assignment or go on to your textbook assignment.
Is that possible to have a hole on the ground, 2 holes on the ground?
Yes, it is. Yeah. When does the hole happen?
When there's some-
When you cancel common factors. Is it possible to have 2 common factors? Probably, right? That's a good question. Because you have a question like that on your assignment. Okay, you saw that. Okay, good. So I'll leave that with you and I'll be floating around to help you out.